What is a system boundary in mechanical engineering? Imagine you're looking at a machine or a process and trying to understand how it works. To do this effectively, you need to decide what parts to include and what to leave out. That's where a system boundary comes into play. It's like an invisible line that separates the system you're studying from everything outside it. This boundary can be a real physical wall or just a mental line drawn in your mind. In system modeling, especially when dealing with complex machinery or processes, defining this boundary is essential. It helps you focus on specific parts, like an engine or a pump, and ignore the rest. For example, when analyzing a car engine, the boundary might include the engine block and pistons but exclude the fuel supply system if it's not relevant to your study. This way, you can better understand how energy flows within the engine itself. In advanced topics and professional practice, the system boundary also acts as a control interface. It determines what can cross into or out of the system. For instance, in a closed system, no matter can enter or leave, but energy like heat or work can. In an open system, both matter and energy can cross the boundary. This distinction helps engineers decide how to model the system accurately. There are three main types of system boundaries. Permeable boundaries allow both mass and energy to pass through, typical in open systems. Impermeable boundaries only let energy transfer, which is common in closed systems where matter stays put. Diathermal boundaries specifically allow heat transfer but might block other forms of energy or matter. Choosing the right boundary depends on what you want to analyze. If you're studying how heat moves through a machine, a boundary that allows heat transfer makes sense. If you're focusing on the entire system's energy balance, you might set a boundary that includes all relevant components. In practical terms, boundaries can be physical, like the walls of a container, or conceptual, like an imaginary line drawn around a set of parts. For example, when modeling a hydraulic system, the boundary might include the pipes and valves but exclude the fluid source if it's not part of the analysis. Understanding and clearly defining the system boundary is fundamental for accurate modeling and control. It helps ensure that energy and mass flows are correctly tracked and that the laws of physics, like conservation of energy, are properly applied. This clarity allows engineers to predict how systems will behave under different conditions and make better decisions during design and operation.